Here is another slide, comparing and contrasting lateral from total surface area. By the way, sometimes instead of saying total surface area, the book just mentions surface area, so it means the same thing. So the two images here are that of, the core of a toilet paper and, Pringles. So, oh, you can hear my kids in the background. So anyway, so these two again have hollow ends, right? Well, Pringles, okay, has a cover and it also has a circular base at the bottom. So again, earlier I mentioned the formulas for lateral area and surface area. Maybe you are wondering, will those formulas change depending on, the base of a prism or if you have a cylinder, okay? The concept of lateral area and total surface area is that this one only includes the lateral faces or the sides, in this case of the cylinder, while total surface area is the entire sides plus the two bases. So if you understand that concept by heart, then you can use the formula, for any prism or cylinder. So for the cylinder, it's the perimeter of the base times the height. But remember, since the shape of a circle, you're not going to get the perimeter in the same way as you get the perimeter of the triangle in the triangular prism earlier. So it's pretty much, it's the perimeter that changes or varies from one shape to the other. And then the total surface area or surface area is again the sum of the lateral faces plus the base areas times, twice the base area because it has a top and a bottom base. So if you remember those two concepts, then you'll be able to adjust the formula depending on what polyhedron you're looking at and what their bases are. So let's try some examples. Okay, I have here a triangular prism. How do I know it's a prism again? Because it has two parallel bases. And what kind of bases are they? They are isosceles triangles, right? Okay, so let's try to find the lateral area here. So LA is equal to perimeter times the height. So remember, your height is the distance between the two bases. So you have your H already. What we don't have is the perimeter. But what's the shape of your base again? Okay, the shape is a triangle. It's an isosceles triangle. Alright, so let's draw the triangle over here. This is 12, right? So if I cut that into half, this is 6, right? So 6, 6. You have a right angle over here. Okay, and then the 8 centimeter here is not for the sides. That's for the altitude of the triangle. So this is 8. Okay, so to find the perimeter, we need to know what these sides are, right? So I'm calling them X, both of them, because it's an isosceles, so they're equal. So how are we going to find X? Yes, I hear you. We're going to use the Pythagorean theorem. So we have 8 squared plus 6 squared is equal to X squared. So that's 64 plus 36 is equal to X squared. So that's going to become 100 is equal to X squared. So that means X is equal to 10. Alright. So now that we know that the legs of the isosceles triangle measures 10 each, we can now find the perimeter. We could just add them all up. So 10 plus 10, 20 plus 12, that's 32 times the height of your prism, which is 20. So the lateral area is equal to 640 centimeters squared. Okay, now let's go to the total surface area. So TSA is LA plus twice the base area. So we already know what our LA is. So lateral area is 640. So now we're going to go back to the base and find the base area. So to find B, let's use the formula for a triangle. It's 1/2, and then the base of the triangle, which is 12, times the height of the triangle, which is 8. So this will be equal to, that's 6 times 8, which is 48. So this will be 2 times 48. So let's get the total. This will be equal to 96. So this will be equal to 736 square centimeters. Now we have a cylinder. So we'll do the same thing. For the lateral area, LA is equal to perimeter times the height. But remember, your shape for the base now is a circle. So to find the perimeter of the circle, you're actually finding the circumference, because that's the distance around the circle. So now that's why when you Google, formulas for lateral area for a cylinder, it will give you another formula in terms of pi, because the circumference of a circle is 2 times pi times r, right? So sometimes they give you 2 pi r h. So where did this come from? It came from the circumference of the circle. But I prefer to use the general formula, ph, because then I only have to memorize one and just, if I understand what perimeter is, then I can get the perimeter of any shape for the base, right? Okay, so going back, so LA is perimeter, which is 2 times pi, times your r, which is 3, and then the height of your cylinder is 9. So then LA is equal to 2 times 3, 6 times 9, so that's going to be 54 pi. We can leave your answer in pi form, or we can actually change it to decimal. So 54 times 3.14, 169.56. So LA is 169.56, and this is inches squared. Okay, so both are correct. If you're going to use this though in another computation, then I suggest keep it in simplest pi form. Yeah, and don't round up intermediate values. Okay, now let's go to the total surface area, which is LA plus 2B. So we know our LA is 54 pi. Okay, plus twice the area of the base. Now you're going to get the base area, which is a circle. So that will be pi r squared. So it's going to be pi, your radius is 3 squared. So this will become 9 pi. So this means it's going to be 2 times 9 pi, which is 18 pi. So when you add them together, you will get 72 pi, right? Okay, well, let's see what that is in decimal. So 72. Oh, what did we do? Okay, so 72 times 3.14. 226.08. So this will be 226.08 square inches. Alright, so those are examples on how to find the lateral and surface areas of prisms and cylinders. Remember the formula, pH for LA and LA plus 2B for TSA.